Hello, it's Wayne Schaefer coming to you from my basement workshop again. A couple of my students came up to me the other day and asked me how I would approach the traditional traffic light programming problem. And as we worked through the solution on the board, they suggested that I create a video detailing everything that we talked about in class. So here it is, the cascaded timer approach for the traffic, or at least one of the solutions for the traditional traffic light programming problem. Okay, so let's take a look at a traditional traffic light. We're just going to use this most simplistic version of the traffic light. Let's say this is traffic light 1, say the north-south light. This is going to be traffic light 2 for the east-west light. And one of the mistakes we make, I guess if you want to say that, or mistakes that students make, is to think that there's 3 timers, one for red, one for green, one for yellow. So let's explore that for a second. So across the top here, I'm going to write timer for green light 1, timer for yellow light 1, and timer for red light 1. I'm going to do the same thing for number 2. Timer for green light 2, timer for yellow light 2, and timer for red light 2. So let's say that the traffic light number 1 is green, so traffic light number 2 is going to be red. Traffic light number 1 turns yellow, traffic light 2 is still red. Traffic light 1 turns red, and in one version, traffic light 2 can turn to green right away. Now this isn't going to be the version we're going to end up with. Let's explore this for a second though. When traffic light 2 turns yellow, traffic light 1 is still red. Now when traffic light 2 turns red, traffic light 1 would turn green again. Well, we already have that up here, so we don't need this line. So let's take a look at what timers we would use. For traffic light 1, green 1, this timer would be timing. For traffic light 1, yellow 1, this timer would be timing. For traffic light 1, red 1, this timer would be timing here and here in this version. We can do the same thing for the green for traffic light number 2. We would be timing green here, timing yellow here, and for red for traffic light 2 we would be timing here and here. Now if you take a look at this, the red timer for traffic light 2 is just a combination of the green timer for traffic light 1 and the yellow timer for traffic light 1. So by rights we don't need this timer. If I take a look at the timer for traffic light 1 red, it's a combination of the timer for green 2 and yellow 2. So again, I don't need this timer. So this is a good example where a little bit of planning we can see that we can implement a traffic light solution with 4 timers. One for green, one for yellow for traffic light 1, and green and yellow for traffic light 2. Now, for those of you that have watched how a traffic light works, this is not the sequence it goes through. We're missing a sequence, and that's when both lights turn red at the same time. There's a slight pause or a slight delay before the next light turns green. So knowing that we don't need a red timer is a good start. So let's take a look at a proper traffic light. So we're going to use the same planning sheet. This will represent traffic light 1. This will represent traffic light 2. And now we know we can use just 4 timers. Timer for green 1, timer for yellow, traffic light 1, timer for red, timer for green 2, and timer for yellow 2. Now let's write down the sequence that we should have written down the first time, which is green and yellow for traffic light 1. Traffic light 2 is going to be red for both those times. Now when traffic light 1 turns red, there is some time where traffic light 2 is red at the same time. Then traffic light 2 turns green while traffic light 1 is red, and traffic light 2 goes yellow while traffic light 1 is red. And again, there will be a brief period of time where traffic light 1 and traffic light 2 are both red. So that's the better sequence to program. So now we can take a look at our timers. For traffic light 1, we're going to be using timer for green 1 for green. For yellow, timer for yellow 1. When traffic light 2 is green, similarly, we'll start with the green timer. When traffic light 2 is yellow, we have a yellow timer. Now we do have these delays, sequence delays between switching from, say, north, south, east, west traffic lights. So let's just call this delay 1 timer and delay 2. So that fills in the gaps here. So switching between traffic light 1 and traffic light 2, we're going to need delay 1, and switching between traffic light 2 and traffic light 1, we're going to need delay 2. Now in all these other boxes, these timers are not functional. So let's just fill these in with zeros, and we get a truth table of sorts. Now this is just one method of creating a table for your traffic light solution. I've seen other tables created, and they're just as valid. Sorry about that one there. So now we can take a look at our timers. For timer for green 1, it's timing while light 1 is green. When this timer is finished, we want to start the yellow timer. So I'm just going to go ahead and draw a line between these two. And I just put a little done here, DN for done. I'm going to circle this, and I'm going to circle that. When timer yellow 1 is complete, it's going to trigger the delay timer where both lights are red. Line over here. And what we're basically creating is a little bit of a state table here. So when the delay between the two lights is complete, I want to switch over to green for light 2. So when that timer is done, and similarly, I can go ahead and finish my modified state table and loop back up here when that's done. So following this kind of nomenclature, really this one under timer green 1 represents when this timer is enabled, or timing. So I'm just going to put an EN by this to remind myself that this is basically when the timer is timing or enabled. So you could put TT beside it, timer timing, just some way to kind of give yourself a note so you know what the timer is doing. So that's given myself a little bit of planning. I know I need 6 timers to complete this traffic light problem, and I have my sequence for the traffic light solution. Now I have seen this done with 1 timer using comparators. That's fine. You can use a sequence using comparators. That's just as valid. There's multiple ways of doing this problem. This just happens to be the one way that I was teaching in class. The one nice thing about planning ahead of time is this is basically language independent. It doesn't matter whether I do this with a ladder diagram or do this in C++ or in Visual Basic. It really doesn't matter what language I use to create my traffic light signal program. The planning stage is language independent. So just remember that. If you sit in front of your PLC programming terminal and you start typing in code without the planning ahead of time, I guarantee that you're going to get hung up somewhere. You might get hung up in thinking that there's 6 timers required for each of the sequences without the delay. So in this case, you'd have a green, a yellow, and a red timer, another green, yellow, and red timer, and then 2 other timers for your delays. And if you try to program this in without planning, it's going to get very confusing. Now, this type of planning also allows me to take a look at how would I program my timers. I can plan that ahead of time without sitting down in front of the computer and programming. So let's take a look at how I would do this with my timers. Now, since I'm at the planning stage, I don't really need to write down any specific addressing. I can just do this with some basic terminology. So I know I need something to start my timer. So let's take a look at my first green timer. I know I need a condition to turn my green timer on. If you remember, that condition was what I called D2 complete. So let's just say D2 done. Again, it doesn't matter whether this is exactly how you're going to program it or not. We're just in the planning stage. And this is going to turn on a timer. Let's just not draw in the line yet. And this is a time on delay timer. And we called this time green 1. Now I know I want to keep that timer running until the next event takes place. So I'm going to go ahead and just create this seal. So while this timer is enabled, I want to make sure this timer stays running until another event takes place. And the event that takes place is going to be that my timer for the yellow light in traffic light 1 starts timing. So this will be TY1 enable. So right now this is just a plan. And if I look at my plan, I can see, well, this is actually going to work for all of my timers. If I follow this same type of idea, TG1 is going to drive TY1, and TY1 is going to drive D1. D1 is going to drive, well, I'll put this back up here, right? D1 is going to drive or turn on TG2, and then TG2 is going to turn on TY2, and etc. And if I follow the same style of programming, I should be able to write this code for each of my timers, and then I'm basically done the timing part of it. So that's a good start. What about my outputs for my lights? Well, if I go back to my planning stage, the green light is only on when TG1 is timing. The yellow light is only on when TY1 is timing. But now if I take a look at the red light for traffic light 1, it will be on when D1 is enabled, when TG2 is enabled, when TY2 is enabled, and when D2 is enabled. So right out of this modified state diagram, I can determine what my logic is going to be for my red light for traffic light 1. And similarly, I can do the same thing for traffic light 2. So if I was just to take a look at the most complex version, which is red for traffic light number 1, I would have D1 enabled, then I would have TG2 enabled, TY2 enabled, and D2 enabled. And all those 4 conditions are required to turn on my red light for traffic light number 1. So now again, at the planning stage, I have a pretty good idea of what my logic is going to look like for my timers and for my lights. And it's all based on just a little bit of planning with this table. So let's go ahead and program it in to the simulator and see how it works. Okay, so now that we've done a little bit of planning, we're going to go ahead and try some programming. I'm going to be using the Learning Pit Logic Pro simulator. It's based on the RS Logic 500 PLC logic. It's a little bit dated, but it works fairly well. It really doesn't matter whether I'm using this software or something more modern. The idea is to get the program code in here, and the program code in ladder is going to be the same pretty much any PLC that I use at this point. Now all the descriptions for the contacts and the timers and the counters have already been added, so I don't have to type all those in, and I've designated what counters and timers I'm going to use in the program. So I'm going to skip the step of doing that part of the planning and just start the programming at this stage. So the first thing we need to do is put our green timer in, which is going to be one of our time on timers. So T40 is going to be our timer for how long the first green light is going to be on. And if you remember, the trigger for this light is going to be the end of the last delay. So we're going to go ahead and put that in here. Now I've already gone through and designated the timer for that, and that's going to be T45, and that will be the done bit from that timer. Now the one thing that I've decided to do is seal my timers in, or basically seal the enable in, until the next event takes place, just as a confirmation that the next event has started before I turn the timer off. Now, PLC programming scans typically from left to right, top to bottom, but if you're using another logic simulator, if you're using a different style of logic, maybe the Siemens Logo PLC as an example, which doesn't quite scan this way, that could cause a few blips in the logic. So if I don't seal it in, think about it from a mechanical's perspective. If these were mechanical relays, I would definitely want to seal them in until the next event takes place so I don't run into mechanical races. So it's just something I'm in the habit of doing. So we're going to go ahead and seal this timer in. I'm going to drag this contact over here, and hopefully I won't talk through everything that I'm doing, but this software is a little bit nice because you can just drag and drop. Now this has to be the enable bit. Again, like I've said, I've already gone in and typed all the descriptions in to make this a little bit easier. Now this timer will stay on until the next timer is started timing. And the next timer is going to be the yellow timer. And again, I've already designated what the timer is. And you should do this planning ahead of time, not just go ahead and start pounding in the program. But in this case, I just wanted to do this a little bit quicker rather than go through and type everything in. All the descriptions in, and I put to 5. This is supposed to be 1. Okay, so that's the time the yellow is on. Okay, so that's our first timer, and if you remember, all our timers are going to follow this format. So let's go ahead and put all the timers in. Okay, so this will be the time that the yellow light is on, and we're going to make that 48 seconds. And there's a reason for this time, and I'll get into it as we start the simulation. Now we don't have to put contacts in right away. We can build our program. The parallel branches unfortunately do show up like this, and you kind of have to drag your contact into there. I want all these to look the same. Okay, now this is driven from T4 0 done. And we're going to seal it in. And we're just going to keep working along here. Now the next event after the yellow is actually going to be the changeover delay, because if you remember, we don't have a red timer. We just have a green timer and a yellow timer. So next is going to be our changeover delay. Okay, and we're just going to keep going ahead and adding timers. And you kind of get an idea of where I'm headed as far as my sequence in the timer logic goes. And we're just going to give this 1 second. It's a 0.1 second timer base. Now the program is going to all look the same. You could probably just cut and paste this whole thing in here. Oops. Now because this is all the same, I'm going to go ahead and stop talking and just enter all my logic in. Now for this last timer, the switchover delay 2, the event that it triggers is going to be green number 1. So this will be cleared when the green number 1 event takes place, which is the enable for that timer. So this is all the timers that we need. So 6 timers includes the delay between the two sections. It's a lot easier to do it this way, basically cascading the timers together. We're sealing in the event, or the enable for each timer, to ensure that the next event starts before I allow the first column tasks. I seal in this task until the next task has started. That way I can actually interrupt the process without losing the previous task, which is another point. So I'm just kind of planning ahead here a little bit, thinking, okay, I might actually need that kind of functionality in the future, so I'm going to program it in. Doesn't hurt to have that seal in there. Okay, so now I can put in my lights. Now if you remember, take a look at our logic table. The first thing we're going to do is take a look at our green light. So the green light, we're just going to designate car2 output 2 as our green light number 1. Again, nice thing about the software is I can just drag and drop the output from their simulation diagram into my logic. Makes it a lot easier to program. Now what triggers the green light is going to be my green light timer. So all I need to put in here is my green light timer. And as long as that timer is enabled, the green light will be on. I can do the same thing for the yellow light. And again, I can drag and drop this right to the ladder. So that kind of makes sense for the green number 1 and yellow number 1. It's going to be driven by those two timers. Now the red is a little bit different. So let's talk about the red for a second. Okay, so let's go ahead and start the output for the red light. And the red light's going to be that output right there. Now the red light is a combination of different timers. Now if you remember back to our planning stage, when green 2 is on and yellow 2 is on, that's when red light number 1 is going to be on. So let's go ahead and put those two conditions in. Now the other two conditions, red light number 1 will be on when either of those switching delays are on. So let's go ahead and put those two in. Okay, so now I've got the first set of red lights, green lights, and yellow lights programmed in. So let's go ahead and do the same thing for the second set. Okay, so that's all the code that we've got to put in here, except for the one thing is missing is how do we start the lights? Because if I turn this on right now, if I program this in, download the simulation, nothing's going to happen. Every timer is driven by the done bit from another timer. There's actually no way to start this unless I force one of the timers to run. So let's go back to our truth table and take a look and see if we can figure out how we want this to start. So here we are back at our truth table, which also serves as our state diagram for the traffic light planning. Just zoom out a little bit here. Okay, now, when we power up, I know that none of my timers are going to be running. They're going to be reset. I don't care the state of my lights at the time, so we're not going to look at our lights. Let me just bring up another line here. We're not going to look at what our lights are doing. So let's just say they're not applicable at this point. And I know that none of my timers are going to be running because they're going to be reset on power up. So that's the state I'm going to be in. The question is, what do I want to do from there? Well, so this state here, all timers off, I want to start the delay 2. If I start delay 2, then both traffic lights will start in the red state, and then I'll switch over to traffic light 1 for green. Now I could start delay 1 instead of delay 2. So alternately, from this state, I could change over delay timer 1. Unfortunately, I managed to freeze my screen, so I'm not sure what just happened there. We're going to go ahead and choose this path, but we're not going to choose this path. This could be an option, though. So from this state, all timers off, we're going to start timer D1. When we start timer D1, both lights will start in their red state, and then we'll move on to traffic light 2, turning to green. Okay, so based on our truth table and what we figured out, we're just going to say if none of the timers are running, go ahead and start switch over delay 1. So that means that the lights will start in their red state, which kind of makes sense. When you start it up, they start in red, and then they sequence from there. And we've just picked switch over delay 1. That's the next light, which is green, is going to be green number 2, and that's going to be our priority where the light starts. And that's just arbitrary at this point. So let's go ahead and put that condition in for the switch over delay 1. Now we can put it right in the rungs, or we could create an internal bit for it, call it a startup task, and maybe we could do that. So let's go ahead and I actually didn't do that originally, but now that I'm talking about it, let's go ahead and put that in as a separate rung. Those 5 timers. Let's just drag and drop those in to get them started. Actually, 6 timers, I'm sorry. So we're going to go ahead and use one of the internal bits in the B3 storage area. Now I can go to the data table here, which is kind of nice to show you one function. And if I pull up B3 for internal binary storage, and let's say I want to use bit number 5 of the first word, I can just grab that and pull that into here, and it enters it in quite nicely for me. Now I'm going to edit the symbol for this, and we're going to call this startup. Okay, so now my switch over delay will also start. So we're going to go ahead and put our startup in here. Graphically, this does some weird things sometimes, so I'm just going to go ahead and move the contacts around where I want them. Okay, so let's see. Oh, I got an extra output in here. Let's delete that. Let's just go ahead and download that into the simulation and see if it runs. Okay, well that's That crash is because I was running the simulation previously and I didn't reset the simulation. So let's let that start up. Okay, we've got a little bit of a glitch, which means I need to go through and find out where I made my mistake. So let's take a quick look at the code. This happens. As I'm talking to you and programming through here, I've obviously missed doing something. So let me take a look and see where I made my mistake. This should be an enable. And maybe some of you saw that while I was typing that in. Okay, had to clean up a few mistakes that I made. As I was talking through this, I wasn't really paying that much attention, or as close as attention as I should have been. I forgot the enables on my contacts up here for the timer. So let's go ahead and download this and see if it works. Okay, so it looks like it's working now. Now, the cool thing about the simulation, if I go ahead and unpark my two cars, I can add some motion to the simulation. The only downside, I suppose, is that the cars don't slow down for yellow. They only stop for red, go for green, and go for yellow. So that creates an interesting dilemma that we're going to have to deal with in a minute. But for the purpose of just a cascaded timer, a red light, yellow light, green light simulation, this works quite nicely. In part 2, we're going to add a few other conditions.